Hello and welcome back to the development of the Feersum scheme compiler. So in the last stream we did some work on debugging, so adding support for emitting a stream that contains the PDB, the program database, the debug information for our main DLL, and then adding some sequence points into that and various bits of information so that the debugger knows whereabouts in our source code corresponds to whereabouts in the generated .NET IL. And the plan today is to move on to moving some of our standard library into a separate pre-compiled binary, because the current way that we do built-in functions is really awkward to add extra stuff. Basically involves manually writing all of the IL in an F# method and then emitting that. So to build anything that's even slightly complex can be quite tedious. So it'd be nice if we could write built-in functions as normal .NET methods in a normal class, just in a standard class library. So that's the aim today. But let's start off by going over what we did last time. So in the binder, we started off by adding a new kind of bound expression called a sequence point. So a sequence point expression was emitted when we bind an expression with a sequence point. So it has an inner expression and it carries the location. So in our initial syntax tree, we have all of this location information about where each node in our syntax tree came from in the source text. And so a sequence point is a way of tying that into the bound tree, where we've got all the information we need to actually emit our IL in the end. And then in our compiler, when we get a bound tree, with a sequence point in it, we emit the appropriate IL. So if we're emitting symbols, so we added a command line flag too, so that you can choose between the debug and release configuration. But if you're emitting symbols, then we basically find an instruction we're going to attach the sequence point to, and then find a document. So we create each PDB file contains like a list of documents, a list of methods, and then a list of sequence points for their methods. So we create a document that corresponds to our source text. We create a sequence point with the start and end position from our syntax tree, and then we just call like method.debug information sequence points add. And then at the end, when the compilation is finished, we write the sequence points, we write all of the PDB information out to a separate stream. So in the original emit, we had just a stream, output stream, and output name, but now we have this optional symbol stream. So if we're given a symbol stream, then we're emitting symbols. And when we come to write out the output at the end, we will tell the writer, here's our symbol stream, you should write symbols. And then we use this PDB, portable PDB writer. So portable PDBs are the new actually documented, runs everywhere debugging format, which .NET Core and so on use, as opposed to the Windows specific old school PDBs. And thanks to all of that, I should now be able to start debugging, and this should, I've actually created a launch test now that just compiles the code that I want to run. So this should hit a breakpoint. Look at that. And if I can step through things. This is a recursive function, so things get pretty crazy pretty quickly. I'm just gonna F5. Same thing. So we have debug symbols, we have sequence points. What's going on with built-ins? So when our compiler starts to emit things, it creates the base type for the program, which is this type here. So it creates a brand new blank assembly and it creates a base type for the program, then passes them both to this function here. So I go find references. I don't know. No. So it calls built-ins create built-ins when it's creating the root context. And then there's this pair here, core types and built-ins, which are used by the compiler to emit things like when we're building lists, we treat there's a type called cons pair, which we treat as a core type. So the core types are things that the compiler needs to know about to be able to emit the code. So at the moment, the two core types we have are the cons type and the environment type. So cons type is the one that's used for creating lists. Env type is the one that's used for creating environments. In the future, this env type might be just the base class of environments. We may have like an environment that's specific to each context. Oh yeah, locals. Let me just rerun the debugger. I don't have huge support for locals, so the way it kind of works is when you in the PDB as well as the sequence points, each method has like a scope, and then scopes can have parent scopes and stuff like that. I just kind of went the easy way in this implementation, and we just have one scope, and the only variable that we emit into that right now is the environment, so the dynamic environment, which is anything that is captured, which isn't, it's better than nothing, but the tree when we come to emit the method doesn't contain information about what each one of our local variables is named anymore. So we don't actually have the information to emit that debug information. And I don't know why this isn't actually starting. It's not hitting any breakpoints because I've not put any breakpoints in there. But say, for example, I'm in here in the inner iterfact with accumulator method. We should see at least one thing in our variables window, which is the dynamic environments. Interestingly, in .NET, in the actual IL, we do get information about the n and the accumulator because function parameters do have names in .NET IL. And if you think about it, that's because if you write a C# method, you can write a C# method and you can use that named parameter where you say like some parameter name colon the value, rather than having to provide a whole load of optional parameters. And the way that the compiler knows what each parameter name is because it is there in the IL. And so the debugger uses the same thing. And then we have this capture environment, which is got our parent environment chain and slots, which is where we're storing all of our locals. But I think there's no actual captured values. Oh yeah. The only thing that's captured really here is the iterfact with accumulator has captured itself from the outer scope, because that's the way that scopes work. And I don't think anything else is actually being captured in that one. Right. So back on to what we do with built-ins. So we have this create built-ins method, which is responsible for, basically, it creates this map where we have all of these names to method definitions. And for each one of these method definitions, there is something like this that goes through and basically builds up a method body, IL instruction by IL instruction, which is really, I mean, there's an awful lot of effort that's gone into just creating this set of methods, which is basically just the arithmetic ones. So it'd be a lot nicer if, especially given the size of the standard library we're targeting, we could write some C# code, just put an attribute on the methods we want to expose, because this kind of stuff can be, what we really need to know is what's the Lispy name for the method, and then have the method, and then that's it. So what I'm going to do is I'm going to start by going and creating a new project for this. And now we could just call this like Feersum.compiler services or something, but seeing as Feersum is named after the book Feersum Engine by Ian M. Banks, I'm going to use another thing from that book. So there's a big castle called the Fastness, and that's named this. So I'm gonna learn to type that a lot. Sarifa. So we'll create a new class library. And I'm going to do this one as C# because I don't want to have to pull in the whole of the F# library into every application that we build using our compiler. Because if you think like C# doesn't really doesn't have a runtime library like the F# one. And if you're writing some Lisp and then you compile it using our compiler, you don't want the resulting thing to be linked not only to the standard library for our Lisp, but also to the standard library for F# as well. So that's the thinking behind that. So add that to be compiled and go and have a look at what we've got. So we've got a wonderful class1.cs. We're going to just leave this one in for the time being because we just want something that compiles. This one's compiled for net 5. We're going to change that to net standard 2 for the time being, even though net 5 is super shiny. The idea being that we want our runtime library to be something that can be consumed from any of the target frameworks that we support, which at the moment is just .NET 5, but it would be nice to support Mono again in the future. Right. And then in built-ins, we've got two different things. So in the compiler, we have the bit where we actually get those built-ins. And the core types. So is there any reason why add core decals could not be inside built-ins? Kind of feels like it could be. It's right at the bottom here. It's a private method, I suppose, but so effectively what we want is we want the call to add core decals and the call to create built-ins to be replaced with like a single thing that says go and discover everything. So yeah, I'm going to move this into the built-ins, and then built-ins is the only thing that has to worry about this. So that can't be private anymore. Compile is going to do built-ins.add core decals. So that's largely happy. Built-ins is not happy because we can't named param. Okay. And it doesn't know about the cons type. I was expecting it not to know about the, this is the core types thing, but we can move that to built-ins. So these core types can move to built-ins. Then compile, we'll do built-ins dot core types. I mean, we could just open built-ins here, but I don't think we use a huge amount from it. Then built-ins named param. What is going on with named param? Create a parameter definition with the given name and type. That kind of feels like it should be in IL helpers. Kind of does. Feels like an IL helper to me. Which should make it visible in built-ins as well. It's private. It shouldn't be private. Now what? There's no red. Let's build it. I'm thinking that maybe built-ins and core is a bit duplication, and as soon as we've got this type here, we'll probably move these built-in methods into core. So let's do that. So then this wants to have, we can now create built-ins private. And we can have our core types do create built-ins. For the assembly and the type. And then in the compiler, we can get rid of built-ins. Just give the program type to the core types. And we can change this, I think, from add core decals to, well, we'll leave that as is, and we'll we'll have a new method, load core, which takes an assembly and it's gonna do add core decals on the assembly. And set the built-ins. Type that hasn't got enough S's in it. Right, and then that means we can make add core decals privates as well. Fix up the compiler. That wants to be load core. The idea being that we can start to get these built-ins from more than one place. What is this unhappy about? Is it even really unhappy? It's unhappy because built-ins needs to be context.core.built-ins. Is that the only place we reference the built-ins? I do that. Save it, modify it, save it. Dance to see if I can get those red squigglies can go away. They seem pretty persistent, but I'm pretty sure that that is correct. It's built and they've gone away. Good. So I'm going to commit that just, well, we can do the F# changes. So this is Move core decals to built-ins. Preparatory refactoring for external standard library. And now with our new library, we need a way. What we're going to do is we're just going to hard code on an extra assembly reference at the moment and see if that works. So normally what you'd do is you'd have like a command line flag and things like that. It would pass in, I'll add this reference, add this reference. But for the time being, we're just going to do something that's going to have a to-do comment. So we've got compile, which does emit. And in emit, we are going to do let Sarifa is type of, let's add a reference first. Need to be able to see this library from our oh dear, I misspelled a commit message. That is terribly unfortunate and very on brand for me. One of my colleagues has got a spell checker that underlines squigglies in comments and things, and my typing causes an awful lot of squigglies. .NET add reference to Sharifa. So now we should be able to pick it out. Like this, and then get the assembly. And we want to add a new metadata reference to our main assembly. Import reference. Can I just do that? Nope. Do we do it automatically with the built-ins? So when we do read from, we might actually already import reference them. So it does method to func. We've got a method reference. It does a method, it does an import reference on the func object. Oh, I know where we can do this. In the built-ins itself. So what are built-ins? we'll just load all the built-ins from that type of expression, and then we'll have it at load time. We create we create a method reference which will import it into the main assembly. So the way .NET works is that if you want to call a method or anything like that from one assembly, you have to have like a metadata reference in the assembly metadata to the foreign thing in the foreign assembly. So let's say load extern built-ins. I think that's the way we're going to want to do it. And then we just want to define this function. So we've got our assembly definition, which you're going to add the metadata references to. We're going to have another assembly, which is going to contain all of our references, and we're going to return a map. We can just return map empty for the time being, and then what can we do with a map? Combine. Change this find key. What I don't really want to do is have to turn one of them into a sequence and then add them all back in. Map.merge was proposed but hasn't landed. Oh well. So if we take the external built-ins and add seek.concat map. Whoops. Seems suboptimal, but I guess it's what we're gonna have to do. It's of seek. So what's that unhappy about? Expression was expected to have type A to B, but it has a sequence of D. think that's because our type doesn't match yet. If I just change these around, it might just fix it. Nope. Oh, do I need to give it all of them at once? Like that. Maybe? But wouldn't that be what the pipe operator was doing? Yes, it was seek to append. So I'm going to go back to the original way. So now in here we can have a bit of reflection to go and find out all of our methods. So let's go and write an example method. So let's not edit in that window. We will start off with an attribute. So we're going to say built-in or Lisp built-in attribute. So our attribute is going to be just a string name, and that's just going to set name. No. No, I don't want expression body. Good. And what we'll do then is we'll look for this attribute on a method. So we'll start off by saying in this class, let's define a method. It's going to have to match up with our unified calling convention. So that's an object test method. Seems good. It's going to take an object array, and this is just going to say, how about we just return params.length count. What's going wrong here? I think OmniSharp's upset. This built-in, and we're going to call it test. If it builds, it builds. No, it's really upset. I bet it's another classic case of the mystery white space. Or maybe I just can't write C#. Thanks for dropping by, Toggle. I'll see you on stream tomorrow. It has been a good Wednesday so far. Ah, Params is a keyword. That has caught me so many times. Ah, this built-in is not an attribute class. Woo. So we need to tell you where you can use it. Attribute usage, attribute target. Let's just expand out that and find out what it is. Yes, attribute usage. We don't have a reference to system yet. That's where we're going wrong. Method, please, and only methods for the time being. And then in load external built-ins, what we can do is do an assembly dot. We want to get all the types. Oh no, external assembly. I think we need to tell. We need to tell this is an assembly. So exported types, and then for each exported type we will find built-in methods. Find built-in methods will take a type and it's just going to return an empty sequence for the time being. Type dot methods. I need to tell it this is a type. Hello again, Ruben. So I'm just trying to scrape all of the built-in methods from an external library rather than having to encode them all manually. So I'm just doing a little bit of reflection to walk through our standard library and try and discover everything that's got some nominal attribute on it. So if we do type get methods, and I think we want to do binding flags public and binding flags static. Because we're not in C#. So if we get all of the methods and then filter them down, seek.where. I thought there was a has custom attribute. Nope. Get I think we're going to need to select these. Seek dot map, and we will produce a pair with the method and the attribute. Less built-in attribute. What are you upset about? Probably because the target assembly doesn't build. Still doesn't build. Didn't imagine the C# was going to be the most difficult part of this. Ah, there we go, it's building now. Back to the built-ins. That should match now. Where? So we're saying like the attribute is not null. Where not is null attribute. And return that. That wants to be the type collection is generic IEnumerable is not compatible with the type. So for each expression type, find the built-in methods. Seek dot flatten. It's a map fold. take some state and a sequence and it returns the sequences of result. Okay, but that's not really what we're going to do. Interesting. Let's map 2. Takes 2 sequences. So I want the equivalent of a select many. Maybe. That is what I wanted. Okay, and then I want to we could do map of seek here. So it's a sequence of something and method infos, and we need to turn it into a sequence of we need to turn it into a sequence of the name to an imported reference to the method. So we'll say name is going to be assert name is attribute not and then the value is going to be assembly import reference that. Hopefully. Main module. Thanks for the hint on concat. I'm sorry I paid no attention to the chat there. So maybe that works. What have we got wrong here? Method reference. Yes, because built-ins, when we're getting them from an external place, are going to be method references, but when we get them from the internal place, they're going to be method definitions because we've just built them. We can just upcast them all to a method reference, I believe. And is that going to work? Yeah. So it's complaining that the elements in the list aren't the same type. So if we have that and then do sequence.map, and then we'll just take name method and just upcast. Maybe things will be better. Might be able to be refactored into sequence.collect ffx concat map might be. All right. If you say so. What does collect do? It takes a mapping of T and a collection. Oh, okay. That makes sense. Look up on an object of indeterminate type. Ah, yes, this is because get custom attribute, I think, actually just returns an object. Or is it because we've still not managed to define something? Still not quite happy there. The type method definition does not match the type method reference. 324. Because built-ins needs to be method reference. Should be fine. No one else should care. Because when we're using these, we don't actually care whether or not they've been defined in our assembly or not. Just need a reference to them. So let's see if the tests pass. They do. Excellent. So now we've got all of these references to external things. Let's see if we can write a test that uses our test method. So let's go into the specs and new file. I'm going to call it test built-ins. And it's just going to call test with, well, it needs to be a list. And at the moment oh no, it's just going to be the list of parameters. So let's say display the result of test, and test is going to say 1 and then false and then hello. And if all is well, we should see it print 3. It's going to fail because we haven't got a snapshot for it yet. Yeah. But what did it do? Diagnostics. Reference to undefined symbol test. Because the binder doesn't know about all of our external symbols. Well, for the time being, we can just put test in here. We need these. We need this scope to be loaded from an external library. Ideally, built-ins would contain would load the built-ins once and provide you a scope and a way to lower them in the compiler. But for the time being, having to list them twice is not really hugely worse than what we already have, especially if we can write the methods in C#. A bit of a refactor later will be fine. Right, what have we got? We've got the snapshot missing. We got some given key was not present in the dictionary. So let us test the tests. In the specs, we have, let's just do a fact. Because I can't run a single test And this is going to do spec tests to compile and run of spec what did I call it? Test built in. Kind of. Ah, yes, because we need to do that at the end. So if we just go and debug that single test, what goes wrong? Clearly, somewhere along the line, the built-in methods are not finding the external ones because the dictionary lookup is failing. So in null.pointer breakpoint and load core as well. Then in here we've got test single, debug the test. Ah, yes, I have to press play. I always forget that. I always end up sat there waiting for it to launch, wondering why my computer's being so slow. And then run parser. Ah, directory not found. It's not good because, well, I assume it's because somewhere up here we've not given it the right thing. The source path. Spec. It's going to be specs. Let's just do specter. Run the test again. Press the play again. Step in. What are you unhappy about? Path. Spec. Use. Yeah, so why have we got two? Why have we got? Maybe I've thought the tests were sillier than they actually are, and this is listing specs and then it's saying joining the spec directory to the, okay, so we actually just need to give it the physically the name of the file. Wonderful. I'll actually get to the thing that I wanted to debug sometime soon. Press the play. Yeah. All right. So load the external ones. And it's going to find the types. Let's put a breakpoint on the type. So if I try and step over there, what type have we got? This should be class 1. What type have we got here? Let's go get the debugging information because the hover is not helping. I think I can read class 1 there. How I can read CLA and the spinner, which I thought the debugger was going to crash. Good. So we've got the type, and then let's put a breakpoint there. No, we can't bind a breakpoint there. Why can't we bind a breakpoint there? Add an inline breakpoint? No. Add an inline breakpoint? Nope. How about here? Yeah. So what have we actually ended up with here? It doesn't feel like it's found any with that attribute on. You know what it is? It's because there aren't any public static methods in class 1, class of classes, because this is an instance method. I'm just gonna boldly try and run that single test, and it's just gonna work. That spinner spinning the wrong way, it bothers me. No, it still failed. Could not find the test, no symbols found. Well, that's a shame. Is it just complaining about the snapshot? Because if it's just complaining about the snapshot, that's good. Maybe we should turn the logging down on those tests. It's nice to see a lot of stuff scrolling past there. Process could not access the file test built-ins because it is being used by another process. Yeah, you can't run those two in parallel. Fair enough. Let us run the task to update the snapshots and find out what we've actually ended up with. Yeah, that's that test single thing not working still. Spec tests, just get rid of that. Actually, could we just skip it? Run the test task. Yeah, here's a little bit for both. Good. So that's passing now, and let's actually, for the fun of it, go and see if we run that spec. We're in the wrong place. If we run spec bin, what do I call it? Test built-ins. Couldn't load the file or assembly. Serifa version 0. Okay, so if we, this is something that we need to work out as well, which is the fact that now we're compiling against an external library, we need a way to make sure that our library is copied into the output directory as well. If we create a proper MS Build project, we can have MS Build do that, but what we probably want is we want the compiler, when we emit it, we probably want to auto copy this just for the time being, because we're not really doing a full MS Build compatible compiler yet. So I'm just going to fix that up manually with, just going to do a manual override of source bin debug net standard .dll. Well, let's just copy it all to spec bin and try and run it again, and we get 3. So that is detecting the built-in from our library, using that attribute, making it available to the compiler, and then having our final program call it. So that means that we can now write in C# Lisp methods and have them callable. So I hope that was interesting. I think I'm going to wrap it up there. If anyone has any questions, I'll answer those before we go. But if not, then I'll see you next time. Quite happy with that. But we do need to have a think about how the copying of the standard library is going to work. Anyway, thanks for watching, and I'll see you next time.